After more than 5 years of design and construction, an engineering first is about to be put to the test. Built by an international consortium of world-class engineers, the ExxonMobil research engine is unique. A scaled-down, working model of a single-cylinder marine diesel. This 1/10 scale engine, now installed at Oak Ridge National Laboratory in Tennessee, reproduces the temperatures and pressures found in a full-size ship's engine, using the same fuel and lubes. New regulations and the pace of technology changes in the industry mean research and development cycles are shorter. Testing new fuels and lubrication oils on full-size working engines requires the regular removal of pistons to measure corrosion and liner wear. The new test engine reduces the need for this, allowing researchers to trial different fuel and lubrication formulas in a fully controlled environment with faster results. It all began as an idea among the scientists and engineers at ExxonMobil's research laboratories in Paulsboro, New Jersey.
Our overall goal was to develop a marine test engine to screen our new technology in terms of cylinder oil and system oils. Basically, the test engine had to match the operating parameters of the marine engine designs that are currently in the field and even into the future.
First, they needed a high-level test facility to host the engine and run the research. Their inquiries led them to the National Transportation Research Center of the Oak Ridge National Laboratory in Tennessee. Here, specialists measure engine combustion efficiency and emissions controls under rigorous scientific conditions. They also assess the energy-saving potential of new fuels and technologies.
Oak Ridge has a number of engine test cells, and we have some very active projects with the OEMs. We've got the experience and we've got a lot of the analytical capabilities and some very unique diagnostics that have been utilized by our partnerships with the big three automotive engine manufacturers.
As far as this particular job, we're dealing with a very large specialty single-cylinder engine here, and we have specific history in setting up engines of this scale for other projects in the past. And it's also a job that involves a lot of lubrication and materials work, and we have some core experts in testing for wear here at the lab also that other facilities don't have.
While the team at Oak Ridge began to prepare a test cell to receive the new engine, the search began for a manufacturer that could design and build a scale engine to the most unusual specifications.
Development of marine lubricants is an ongoing endeavor. There are many changes in the industry that have taken place, a lot of it revolving around emissions control and fuel efficiency. We're basically trying to simulate a full-scale crosshead diesel engine, which could be as high as 100,000 horsepower per engine, in a single-cylinder engine that is 1/10 the size.
Many specialist engineering companies across North America and abroad were approached in an effort to find one that was prepared to take on the challenge.
We did somewhat of a broad-based international study and looked at various manufacturers that would be able to build the type of engine that provided the requirements that ExxonMobil needed, and MAHLE was chosen for that particular task.
MAHLE Powertrain is one of the world's top suppliers of custom-made engine systems and mechatronics, with a high level of expertise in thermal management, a vital requirement of the test engine design. After running extensive computer modeling in Detroit to check whether ExxonMobil's exacting technical requirements could be met, they agreed to take on the challenge and began to put together the project team.
We have a really diverse group of engineers that work on our project teams with a lot of experience working in different engine applications. We have a lot of single-cylinder engine experience specifically, which is a really unique aspect of this engine.
Oh, this is as different as it gets. There is no engine like this. It's absolutely unique.
MAHLE Powertrain thrives on technical challenges. We always say if it was easy, everyone would be doing it.
Starting with an empty workshop floor, the team gradually began to assemble the unique engine. calling on the custom fabrication talents of specialist contractors around the USA and beyond. But finding even the most basic off-the-shelf components was proving a challenge.
Most of the industry around here is geared up around automotive or in some cases heavy-duty diesel, but nothing quite this size. Conversely, a lot of the marine engine component suppliers are used to delivering components at a much larger scale, this being a 1/10 scale. So we were kind of stuck in this middle ground of too big for the automotive suppliers, too small for the marine diesel suppliers.
Among the many unique technical requirements was a fully functioning oil flow control system, but in miniature.
The cylinder oil is used to lubricate the piston rings and liner, and it's very important to have an accurate flow of cylinder oil to the liner and consistent flow to make sure our experiments are well controlled over time.
Despite an intensive search, no US supplier could be found. So they went across the Atlantic Ocean to the tiny town of Hadsund in Denmark, home to Hans Jensen Lubricators, a family-run engineering company with a 100-year-old reputation for excellence.
The technical challenges was quite big because normally two-stroke diesel engines is having a revolution takt of 100 revolutions per minute. In this project, one of the issues was 600 revolutions. And normally we have an injection of a certain amount of lube oil, and in this particular case we're talking about 1/10 of what is normally injected.
Because each component of the design is unique, there was no possibility of building prototypes or running tests. The thousands of hand-built, custom-made components were assembled for the first time at the Mahler plant in Detroit. Computer simulations indicated it should work when put together, but nobody could be sure until it was started up for the first time. The whole machine was then pulled apart again and loaded onto a truck bound for Oak Ridge, Tennessee, where the engine was carefully rebuilt in the test cell that would become its permanent home, ready for its all-important first firing. Now all is ready. Last-minute checks are carried out. For the designers, the constructors, and the test team, the moment of truth has finally arrived. Will it work?
Ignition.
2 months after the first successful firing, members of the ExxonMobil team, Mahler Powertrain, and the Oak Ridge National Laboratory gathered to officially launch the research program.
Well, we're trying to do step-out research. We're trying to be innovative, develop the next generation products that the business needs to sell. So this will give us the tool that we need to develop those products for the future.
Now that it's up and running, the Marine Engine Test Facility will start a 10-year program of experimental analysis, which will help maintain ExxonMobil's reputation at the cutting edge of marine fuels and lubrication research.